Good morning, everybody. The questions are on screen for you there to have a go at. Pause the video here if you would like to have a go before I have a go, or have a go along with me. That's absolutely fine. So I'll put them in the corner there. First one, in figures record 60,424. So that means, figures means digits, so it's 60,424. Okay. 67.47 times 1,000. So I'm going to get 67.47 written out. 67.47. If you multiply by 1,000, then everything's going to move 3 place value columns to the left. So let's choose, let's just choose the tenths. So it's going to go 1, 2, 3. So the 4 will end up in the hundreds. Oops. So you're going to have 4 in the hundreds, 7 in the tens, that unit. Okay. And the decimal point should be there. Okay, and let's just check. So this was units, this was tens. So if tens is going to jump 3, it'll go hundreds, thousands, 10,000s, sorry. 67,470, yeah. Okay, you can tell I haven't done maths in a couple of weeks. It's a bit rusty. 78.92 divided by 100, so it moves 2 place value columns to the right. I don't know what I did there. 1, 2. So the 7 is going to end up in the 10th. So it's 7, 8, 9, 2. So I'm putting there 0. Okay. If you were to draw your place value columns out, you'd find that an awful lot easier. It's just, obviously I'm confident with my place value columns, I don't need to put them in. You'll also notice that you've got this place value column that you haven't used before. But obviously it does exist. The number doesn't just stop there. They do carry on. A sixth, add 5 sixths, well that's easy. 1 sixth, add 5 sixths. Okay, if the denominators were different, I'd have to make sure that they weren't different, otherwise they wouldn't be able to interact with one another, but they're the same, so I can just add the numerator, so it's 6 sixths, but obviously 6 sixths is the same as 1. Okay, if you have a pizza split into 6 pieces, can't do this now, like that. Yeah, 6 pieces, and you eat all 6, you've eaten a whole pizza. 3/10 recorded as a decimal. Did loads of work on decimals before half term. So if 10/10 equals 1 whole, then you need to take your whole and split it into 10 equal pieces. Okay, 0.1. And you've not got 1 equal piece, you've got 3. Okay, so you take 0.1 and times it by 3 is 0.3. Okay, divide by the bottom, times by the top. 14 divided by what? 14 subtract what is the same as 60 divided by 6. 14 subtract a box equals 60 divided by 6 is obviously 10. So I'll just put that there. 14 subtract 4 is the same as 10. What is the value of 6 in this number? I'm not going to read it out because, oops. My apologies there, because I'll give it away. So you've got your units, tens, hundreds, thousands, 10,000, 100,000. Okay, so it's 100,000. Ah, no, sorry. That's the column it's in. What's the value? Is 600,000. My apologies, 600,000. 78.934 rounded to the nearest whole number. Take this place value, ignore that. Look at this place value column, because that's the smallest whole number digit to units. So to decide whether you round up or down, you go 1 to the right, it's 9, so it'll round up, so it's 79. Okay, 79.0, or just 79. Continue the sequence with 5 more terms. So you establish the rule, and then go from there. Well, I can spot that's the 7 times table. You've got 7, 14, 21, 28, 35. Okay. So it's started at minus 35 and going forward, I suppose, towards positive numbers. So it's adding 7 each time, just starting with a minus. So the next one will be minus 7, and then it will be 0. And how many does it need? 5. 1, 2, 7, 14, 21, 1, 2, 3, 4, 5. Perfect. Okay. So that one, dead simple. It's all about establishing the rule, making sure as well that the rule doesn't change between numbers, because it can do that. So this might have added 7, then it might add 8, then it might add 9, for example. So you need to make sure that the sequence, the rule that you think you've got for the sequence is definitely correct. Round 86.57 to one decimal place, 86.57. So you're looking at this digit, this place value column, so you move 1 to the right, 7, so it rounds up, so it's 86.6. Okay. Right, those were nice and easy to start us off with. So I've got a challenge question now. He says, here. Again, as usual, pause the video, have a look at it yourself, and then we'll come back and do it all together. So this one, quite tricky actually to get your head around. So I'm going to draw some pictures to help visualise it. Hopefully it helps visualise it for yourself, but it's definitely how I would be needing to visualise it. So I'll just zoom in this. So what are they doing? They're trying to add £40 and 5p. No, don't want that, because that says £40, 50p. 40.05, and they're trying to add that to £29.97. Now the whole point isn't just to add it. They've decided to round this to 40, and they've decided to round this to 30 to get an estimation of 70. Okay, which is fair enough. Nice, sensible method. But their problem now is, what do they do to get it back to the original answer? So these are the three theories. Noah says that you take 5p and you subtract 3p. So you get 2p. So we need to add 2p to £70. Poppy thinks that 5p add 3p is 8p, so we should add 8p to £70. And Liam says it's 3p subtract 5p, so we need to minus 2p off, so we need to take 2p off from £70. So what they're saying is, there's obviously a 5p disappeared there, and there's a 3p, well, appeared there. Okay. So there's a change. There's a change of 5p here, and there's a change of 3p here, which is where they keep getting the 3s and the 5s from. But what do we do with it? So what I'm going to show you is, just working out how I want to show it myself, actually. Didn't mean to do that. Okay, so if you take £40 and 5p, and you turn it into £40, you've gone backwards by 5p, okay? Which means that at the end, you need to add 5p on. What am I doing today? Can't spell on. Goodness me. Add 5p on, okay? That looks like an S as well. So you add the 5p. So I've taken it off now to add it on later, okay? So the £29.97 I've turned into £30, or they've turned into £30, and they've done that by adding 3p. Okay, probably should have had it the other way round maybe, but point still stands. So they've added 3p, which means at the end, I'm going to have to subtract that 3p back. Okay, hopefully you can see where I'm going with this now. So if I need to add 5p on to my answer, but I also need to take 3p off my answer, then isn't that and that just the same as adding 2? If you add 5 and then take 3, or you take 3 and then add 5, whichever way around you do it, you're adding 2p. Okay, which means that the correct answer is Noah. 5p subtract 3p is 2p, so we need to add 2p onto £70. So the answer is £70 and 2p. And then we can check that as well, just to make doubly sure I've got it right, by adding up what I've been asked to add up, £40 and 5p. This wouldn't help you get the answer, but it helps you check your answer. Okay, and straight away you're going to see 5 and 7 is 12, so I've already got that 2. And I'm going to carry the 1. No, 0. There you go, 2p. And then this is going to add £70 and 2p. Okay, so it's definitely Noah. Adding them up at the beginning is no use because it doesn't help you get your head around whether you're adding or subtracting and so on and so on. But using it to check your answer, absolutely fine. So for that one, Noah. Right, I will see you in tomorrow's video.